Hello everybody, and welcome to example 1 on page 57. This is going to be our first example of actually working with matrices of compositions of linear transformations. And let's take a minute just to read this example. We're going to be working through part A in this video. So define t going from R2 to P2 of R, okay, by this formula, and u going from P2 of R to R4 by this formula. Okay, and to keep it simple, we'll let alpha, beta, and gamma be standard ordered bases of our three vector spaces, R2, P2 of R, and R4. Okay, and part A would like us to calculate the matrices of those two linear transformations T and U separately. Okay, this is the type of calculation that we've done before. Okay, so for the matrix T, for example, we can look at that and notice that we're starting with the basis alpha, and that's a basis for our first vector space R2, since that's the domain of our transformation. So the standard ordered basis of R2 is just the vectors 1, 0, and 0, 1. That's what we're going to substitute into T. Okay, so we'll start there. And we have a formula for T that looks like this. Okay, so to calculate T of 1, 0, we're substituting in A equals 1 and B equals 0, and if you do that in that formula, here's what you're going to get. 1 plus 1x plus 0x squared. Okay, and then similarly for T of 0, 1, now it's A that's 0 and B that's 1, and you substitute those numbers in, you're going to get 1 minus 1x plus 1x squared. Okay, and to make our matrix, notice that our codomain here is P2 of R, and so we're talking about the standard ordered basis of P2 of R, which is just 1x and x squared. So to get the columns of our matrix, we just need to look directly at these coefficients. Okay, so the numbers that I just circled should be the first column of our matrix for T. Okay, so that's going to look like 1, 1, 0. Okay, and then the second column is going to be those three numbers. So 1, negative 1, and 1. All right, and we're halfway there. So that's the matrix of our first transformation. Okay, and we're ready to move on to the matrix for U now. Okay, and there we're starting from the basis beta, and that's actually the basis that goes the standard ordered basis for P2 of R, if you read through the problem again. Okay, so this time we want to take the three polynomials 1, x, and x squared and substitute those into the transformation U. Okay, now notice where the formula for U is. Okay, that's sitting right here. And the thing that I would call your attention to is that we're going to get a 4 tuple out. Notice that 0 is going to be the first entry in that 4 tuple regardless of what p of x is. So what we can say here with confidence is that for all three of these things that we'd like to substitute in, we know that we're going to get a 0 for the first coordinate. Doesn't matter at all what the p of x is that we're plugging in. Okay, so with that established, let's look at these one at a time, starting with u of 1. Okay, and in the notation of our function, that means that this 1 is going to be our p of x. Okay, and kind of looking back at our function, I'm moving back up to the top of the page on you here. These are the three numbers that we need to figure out: p of 0, p prime of 0, and p double prime of 0. Okay, so let's go to the bottom of the page and see if we can do that. Okay, in our case, p of x is 1. So p prime of x, its derivative is going to be 0, and then its second derivative is going to still be 0. And we'd like to substitute the number 0 into all of those. Okay, so if you do that, okay, p prime of 0, p double prime of 0. The thing about it is, all three of these functions that we calculated are constants. Doesn't matter what we plug in for x, we're going to get 1, 0, 0, okay, out of those three things one at a time. Okay, so that 1, 0, 0 then is what goes here. Okay, that's our p of 0, p prime of 0, and p double prime of 0. Okay, so we've got our first output. Okay, and just to warn you here, because there's kind of a lack of space here, I'm going to be erasing over the top of some things that I wrote. So you may need to, if I'm going too fast, feel free to pause the video, but I'm going to get rid of this down here and kind of reset for the next round. All right, and now our next p of x is x. And we're interested in the derivative and the second derivative of that. Okay, so the derivative of x is 1 and the second derivative is 0. And again, looking back at the top of the page, we need to substitute 0 in for each of those functions that we calculated. So p of 0, p prime of 0, and p double prime of 0. We're going to get those three numbers by just taking these three formulas and substituting in x equals 0. Okay, so in the first case, substitute in x equals 0, we get 0. And the second two, the 1 and the 0 that we got are going to stay the same. Okay, so that 0, 1, and 0 are going to be our last three outputs there. Okay, and again, erasure warning here. We'll get rid of that. And now we'll move on to what about x squared? All right, well, if p of x is equal to x squared, then its derivative is 2x, second derivative is 2, and we're going to take and substitute 0 in for all of those. So let's see, 0 squared is 0, 2 times 0 is 0, and then if we plug in 0 to a constant function, we're just going to get 2 out. So our last three numbers are just 0, 0, and 2. Okay. So we've got our three outputs. How do we make our matrix for u now? That's the next question here. Okay, well, take a look at what the basis is for our outputs. Okay, when we look at this matrix for u, output basis is gamma. Okay, so we want to take all three of our outputs and write them as linear combinations of the basis vectors in gamma. Okay, and the nice thing about the basis gamma is it's just the standard ordered basis for R4. So if you take this 4 tuple, for example, all we want to do is to write it as a linear combination of the standard basis vectors. Okay, this is a lot of writing here. 0, 0, 0, 1. Okay, and since the standard basis vectors are nice, not difficult to figure out what needs to go in the blank here. We're just going to get 0, 1, 0, and 0. And those four numbers should be the first column in our matrix. Okay, so the matrix of u taking us from beta to gamma, first column of it would look like 0, 1, 0, 0. Okay, notice though that kind of an interesting thing happens here. That first column exactly matches the coordinates in our tuple. Okay, that happens just because of the fact that our basis is standard. Okay, it's such a nice basis to work with. And that's going to happen for the last two as well. Okay, so the second column is just going to be the 0, 0, 1, 0 that we got right here. And then finally 0, 0, 0, 2. Okay, so there is our matrix. And we are done with part A. So in the next video, we will continue with this problem.